Okay, so good evening, everyone. So, our topic for today is about Chapter 12 Contents, the LAN concept. So, it deals with the LAN concepts. And let's start. Of two devices that, for the wireless NIC, sorry, have a radio transmitter and a radio receiver tuned to the same radio frequency. It means that end devices with wireless NICs, a network device such as wireless router or wireless AP. To communicate wirelessly, laptops, tablets, and smartphones, and even the latest automobiles include integrated wireless NICs that incorporate a radio transmitter receiver. However, if a device does not have an integrated wireless NIC, then a USB wireless adapter can be used as shown in the figure. What I'm telling about as shown in the figure is, there is a certain device that is connected to the device, and it is the wireless NICs. Okay, but note, many wireless devices you are familiar with do not have visible antennas. They are embedded inside smartphones, laptops, and wireless home routers. Like what I've said before, it is wireless. What means the means of wireless is there's no wire on it. There's no antenna. You can see anything that may happens to be called as wired, so it is called wireless. And those wireless connection or those antennas that we cannot see, it is developed or it is embedded inside the devices itself. Next one is the wireless home router. We're always familiar with the wireless home router. So when we talk about wireless home router, we're talking about Wi-Fi. Why? Because the type of infrastructure device that an end device associates and authenticates with varies based on the size and requirement of the LAN. For example, a home user typically interconnects wireless devices using a small wireless router as wireless router. Wireless router serves and first access points. This provides 802.11a-b-g- AC wireless access. Switch. This provides a 4-port full duplex 10-100-1000 Ethernet switch to interconnect WAN devices. And last is the router. This provides a default gateway for connecting to other network infrastructure such as internet. And a wireless router is commonly implemented as a small business or residential wireless access device. This wireless router advertises its wireless services by sending beacons containing its shared and service set identifier SSID. Devices wirelessly discover the SSID and attempt to authenticate with it to access the local network and internet. So mostly the wireless connection or the wireless router are now being used in the computer shops. As you can see, there is and also those wireless connection is, it has a really connection in the Wi-Fi or in the internet itself. And most wireless routers also provided advanced features such as high-speed access, support for video streaming, IPv6 addressing, quality of service or configuration utilities, and USB ports to connect printers or portable devices. Additionally, home users who want to extend the network services can implement Wi-Fi range extender. A device can connect wirelessly to the extender, which boosts its communication to be repeated to the wireless router. I said here that there are certain features that very obvious that is only for very obvious that the wireless can do. Where is the high-speed access? High-speed access in terms of what? For example, in internet, there is a high-speed access because you know the wired will not serve as a distraction anyways because it is wireless. There is no one connected to your device and to the internet. So and sometimes those wired connects or those wired, if something is being broken on those wired, it may lead a certain it may lead a certain delay from the access in the internet when it happens. Next one is the 802.11 wireless topology modes. For the wireless LAN can accommodate various of network topologies. The 802.11 standard identifies two main wireless topology modes, AD hoc mode and the infrastructure mode. Tethering Tethering is also mode sometimes used to provide quick wireless access. For the ad hoc mode, this is when two devices connect wirelessly in a peer-to-peer P2P manner without using APs or wireless routers. Examples include wireless clients connecting directly to each other using Bluetooth or Wi-Fi direct. The IEEE 802.11 standard refers to ad hoc network as independent basic service at IBS. As listed as example of the ad hoc mode is the Bluetooth. Yes, there is no you can connect in two devices using Bluetooth. It is it's a peer-to-peer or one-by-one connection, and it is the ad hoc mode. Second one is the infrastructure mode. This is when wireless clients interconnect via wireless router or AP such as LANs. APs connect to the network infrastructure using the wired distribution system such as Ethernet. The last one is the tethering. Tethering. Are you familiar in your phone when you use the tethering portable hotspot? So it has connection with this. A variation of the ad hoc topology is when a smartphone or tablet with cellular data is enabled to create a personal hotspot. Like what I've said before, a hotspot, tethering hotspot mode. This feature is sometimes referred to as tethering. A hotspot is usually a temporary quick solution that enables a smartphone to provide a wireless services of a Wi-Fi router. Other devices can associate and authenticate with a smartphone to use the internet connection. Like what I've said, this tethering is giving the chance the user to use their smartphones as as a wireless or as a Wi-Fi, as a wireless router by means of opening your hotspot, your personal hotspot, and just letting other devices to connect it with you. And be sure that you also have your data access, so that they all can also connect in the internet. Next one is to the CAPWAP or the CAPWAP. CAPWAP is an IEEE standard protocol that enables a WLC to manage multiple APs and LANs, and CAPWAP is also responsible for encapsulation of and forwarding of LAN client traffic between an AP and WLC. CAPWAP is based on LWAP but add additional security with datagram transport layer security. CAPWAP establishes tuneless or user datagram protocol (UDP) ports. CAPWAP can operate either over IPv4 or IPv6 as shown in the figure, but uses IPv4 by default. So it is said that it may use in IPv4 and IPv6, but this CAPWAP is uses by default by IPv4. IPv4 and IPv6 can use UDP ports 5246 and 5247. However, CAPWAP tuneless are different IP protocols in the frame header. IPv4 uses protocol 17 and IPv6 uses IP protocol 1.36. So there's IP protocol 136. So there's a big difference with it. Next one is the channel management. For the channel management, frequency channel saturation. Wireless LAN devices have transmitted and receivers tuned to specific frequencies and radio waves to communicate. A common practice is for frequencies to be allocated as ranges, such ranges are split into smaller ranges called channels. In the demand of a specific channel too high, the channel is likely to become oversaturated. The saturation of the wireless medium degrades the quality of the communication. Over the years, a number of techniques have been created to improve wireless communication and sorry, alleviate saturation. These techniques and meet, can me this technique mitigates channel saturation by using the channels in a more effective, efficient way. So this example of those channels that I'm talking about right now is the direct sequence spread spectrum or the DSSS. This is a modulation technique designed to spread a signal over a larger frequency band. Spread spectrum and techniques were developed during wartime to make it more difficult to enemies to intercept or jump communication signal. It does it by spreading a signal over wider frequency, which effectively hides a discernible peak of the signal as shown in the figure. So they make an example that this kind of thing or this kind of channel is being used when there is a war, because mostly in war they are using their walkie-talkie. What is walkie-talkie? If I know about it, it is the thing that they can talk to their commander, to their fellow soldiers or fellow men to to know where are they, and by the use of this direct sequence spread spectrum or the D triple S, it may, you know, distract the signal so that they cannot communicate well. Okay. Next one is the frequency hopping spread spectrum, or the FHSS. This relies on a spread spectrum method to communicate a transmit radio signal by rapidly switching a carrier signal among many frequency channels. With the FHSS, the sender and receiver must be synchronized to know which channel to jump to. This channel hopping process allows for more efficient usage of the channels, decreasing channel congestion. FHS was used by the original 802.11 standard walkie-talkies, and 900 MC cordless phones also use FHSS, and Bluetooth uses a version of FHSS. So, in connection for what I've said before, that this frequency hopping spread spectrum, or the FHWS, a connection also in wars, because the like what I've said, that the soldiers are using their walkie-talkie, and walkie-talkie has a 900 mH or 900 megahertz. Cordless phones also use FHSS, and also Bluetooth that we're usually using today has a variation of FHSS. Lastly is the orthogonal frequency divisional multiplexing, or the OFDM. This is a subset of frequency division multiplexing in which a single which a single which a single what is it? which a single I'm sorry which a single channel uses a multi-subchannels on adjacent frequencies. Subchannels in an OFDM are precise orthogonal to one another, in which allow the subchannels to overlap without interfering. OFDM is used by a number of communication systems, including 802.AG/G/M/AC. And that's it. And wireless security overview. A LAN is open to anyone within a range within a range of credentials to associate it with a wireless NIC and knowledge of cracking techniques. And other attacker may not have the physically to enter the workplace to gain access to a LAN. Attacks can be generated outsiders in this, the employees, even unintentionally by employees. Wireless networks are specifically susceptible for the several threats, including interception of data. What is interception of data? Wireless data should be encrypted to prevent it from being read by eavesdroppers. Next is wireless intruders. Unauthorized user attempting to access network resources can be deterred through effective authentication techniques. Denial of service, or DOS attacks. As of DOS attacks can be deferred through effective authentication of techniques, and denial of service attack or access to LAN services can be compromised either accidentally or maliciously. Various solutions exist depending on the source of the DOS attack, and rogue APIs, unauthorized apps installed by well-intentioned user or for malicious purposes, can be detected using management software. And next one, and that deals chapter 12 contains the LAN concept. Those are the concepts, or those are the things that deals with chapter 12. And this chapter tackles about the wireless devices or the wireless routers that we're using today. And it may also help us to know on how to use it well and how to know their uses, more likely for us to be more knowledgeable and how to know those kinds of things or those wireless things that we are using in this era. Thank you so much. I hope you've learned something in this video, and that was all. Goodbye.